All right, let's go ahead and take an example here that we didn't have time to look at in class, and it's just basically going to keep applying those same definitions that we just talked about. So if we take a look at this example, it's asking us to determine the values of these constants here, c and m, so that the function h of x is continuous for all x values in the domain. So in order to do this, we kind of need to apply that definition we talked about, which simply states that we know that the limit as x approaches 1 of our function h of x needs to be equal to the function evaluated at 1, so h of 1. And we can kind of unpack this a little bit further and say, okay, the limit means that we need to do the limit as x approaches 1 from the left of our function, and that should be equal to the limit as x approaches 1 from the right of our function, which needs to be equal to our function evaluated at 1. We already know that this function is continuous everywhere else besides 1, because if we look at where x is less than 1, we can see we've got a polynomial function, and all polynomials are continuous. Same thing when x is greater than 1. We have another polynomial function, so we know it's continuous everywhere after 1. We just kind of need to show that it's continuous at 1, and we've done everything that we need to do to show that it's continuous everywhere. So let's take these limits here. We'll do the first one. As the limit approaches 1 from the left, we can use our direct substitution. We get c times 1 squared, or just c, and that should equal, when we do the limit of h as x approaches 1 from the right, so we're going to use the x greater than 1 branch. Again, we'll use our direct substitution. Negative 1 plus m times 1 gives us m minus 1. And if we evaluate h of 1, we'll use our middle branch of x equal to 1, and that's just 4. So we've kind of got this long equation here. If we just pair up a couple things at a time, it's pretty easy to see that c needs to equal 4. And if we pair up the middle and the end, we'll have m minus 1 equal to 4, or m is equal to 5. So if we were to evaluate this function with those constants plugged in, we'd have a piecewise function that's continuous for all x values.